The title of this paper is On-Demand, Spot, or Both: Dynamic Resource Allocation for Executing Batch Jobs in the Cloud. And this work is from the Microsoft Research. As you all know that the cloud is a growing business, and there are a lot of purchase options with a lot of varieties. You have the options like which computing resource you have to purchase and what time you want to purchase it, and where you want to purchase it. Are you going to purchase it from Microsoft or from Google or from Amazon, etc.? However, the price calculator and auto scale mechanism that are currently available, they are not enough. We need some automatic adjust purchasing decision as a function of dynamically evolving conditions or workloads. So this work is based on automatic resource allocation for the batch jobs. It actually focus on the compute instances. And currently there are several options available like on-demand, which is a bit expensive, spot instances, and reserved instances. However, they are not considering the reserved instances in this work, but they are only considering the on-demand and the spot instances, and they are automatically switching between them and choosing the best one for completing a task. So the on-demand instances, you purchase it for time and it guarantees to complete your job, but they are more expensive. It is possible that you could not utilize all of your computing resources that you have already purchased, but still you have paid for it. The spot instances, on the other hand, whenever you are looking for extra or surplus instances from the other users, and when they are available, the Amazon or the Google services, they just put it on low prices, and the user can buy those instances on some bad pricing. They are very cheap. But when you are buying those instances and when you are switching between the spot instances, it causes some interruption and delays. And sometimes this kind of interruption and delays could be very dangerous for completing your tasks. As you can see in this picture, the on-demand price, it's fixed and there is no change. Like you just pay for 1 hour and all the resources are yours. So no matter you can use it or you cannot use it, but they are yours. And you can use them for completing your task. But on the other side, the fluctuating bars that you can see here, they are the spot market prices. So the spot market prices sometimes even exceeds the on-demand price. But for most of the time, they are available at very cheap prices. So if you can somehow opportunistically find them, you can purchase them and you can maybe complete your job in time with very low cost. This would have been better if there was a policy that whenever these are available, you can use them, but when they are not available, you can switch to the on-demand and then you can use on-demand instances at that time. But currently, they are not available, and that's what this paper is proposing, an automatic way to switch back and forth between the on-demand and spot instances. This is the outline of their paper. The first one is the job model. So their job model has 4 tuples: the arrival time, the job size, the parallelism constraint, and the value function. What is the job arrival time? The job arrival time is the time when the job is available. And then it also has a deadline. So each job has an arrival time and it has a deadline time. Deadline time means that within this duration, I need this job to be completed. Job size, the job could be a small job or it could be a very huge job. So the job size also varies. And it is denoted by this bar with Z. Parallelism constraint, it is a threshold. When the job size exceeds this thresholds, then the job is handled by parallel instances. And finally, there is a value function. Value function is the value when the job is available till the deadline, and it is a monotonically increasing function. So the most important thing here is from all these 4 tuples of the job model, they extract the utility function. The utility function is the difference between the value and the cost of the resources. So their objective is to maximize the job utilities. To illustrate the job resource allocation, they restrict attention to a single size job. So the decision on the job could be on demand or it could be a spot or bid. So what is the relation between the spot and bid? I'll just briefly explain it here. There is a market price of each spot which is available. So the spot is coming from the instance that has not been used by the other user. So the cloud make those instances available for the others, and the others can buy or purchase those instances on very low prices, on cheap prices. But to purchase that, you have to put some bid for that. And if you have a bid there and that price is lower than that bid, you can easily purchase those instances. So the resource allocation can modify decision every hour. They have the spot instances available with 5 minutes of resolution window, and then they keep checking for next 5 minute window. Do we have the spot instances available or not? If they have, they keep using it. But sometimes they don't have the spot instances available anymore. Right at that time, they switch to the on-demand services. But on-demand services, they cannot buy it for less time. At least they have to buy it for 1 hour. So then they purchase the on-demand services for complete 1 hour, and again they come and check if there are spot instances available there. If they are, then they keep oscillating at that region. But if they don't have the spot instances, again they go for the on-demand. So this is how they switch back and forth between the spot instances and the on-demand instances, and they keep accomplishing the job with least possible cost. So here is the big picture of their algorithm. They have a set of parameterized policies. I'll just explain the parameterized policies in the next slide. So when the job is arriving, they are attaching a policy to it. The policy is picked and random. So it's not like they have a lot of policies and they are assigned to the job based on FIFO. No, there are a lot of policies available. But when a job is arriving, it is randomly picking any of the policies. If that policy is not working for it, then it is choosing another policies. And the policy to be chosen has the highest probability to be chosen again if it has successfully completed the prior jobs. So the main task of their online learning algorithm is to update the probabilities. Update the probability means that if the prior task has been completed by a policy, then that policy has high probability to service other jobs too. So this kind of probability is being updated by this online algorithm. Although they have good performance with this online algorithm, yet they don't know in advance that which policy will work better. Now, what is parameterized policies? First, choosing between on-demand and spot policies. So there are two types. One is deadline centric. Deadline centric means that they start the job to be finished with the spot instances. However, when the deadline is getting approached, or when the deadline is very closer, and they come to know that we cannot finish it within this spot instances, then they switch to the on-demand instances. On the other hand, the rate centric is a fixed and on-demand instances. It never goes to the spot instances. They just work on the on-demand. Second, when they are using the bidding on spots instances, what kind of bid are they using? They are using two types of bid. First, they can use the fixed bid. Fixed bid means that throughout the job completion time, they are putting only one bid or one bid pricing, and within that one bid pricing, if they have the instances available, they just buy those instances. Otherwise, they don't update the bidding. In contrast, the variable bidding is different. And variable bidding, if the market prices are not available within this bidding, they slightly increase the bidding price. They keep varying the bidding price such that the instances are available so that they could have more instances and they could benefit from that. And the third, can they abandon the job? The answer is yes. They can abandon the job based on two conditions. One is the value versus cost, which means the expenses. If the expenses is surpassing, then they can discard their job, which means that if the cost is higher than the value of the job, they simply discard the job. And the other one is the deadline versus remaining compute, which means that the deadline is approached, but the job has not been finished yet. Then in that case, the job is again discarded, because when the deadline is approached and the job is not yet finished, but half of the job is still remaining, and that time, again, the job is abandoned. So in summary, the policies are deadline centric and rate centric, and the bidding are fixed or they could be variable. So how the online algorithm is working? So the main loop is running for each job. When the job arrives, then all the policies are checked for these jobs. And within the policy, the utility function is computed. And alongside the utility function, they also compute the weight function, which is increasing exponentially. However, the main drawback is the utility function is not coming in real time, but it is delayed feedback. And this delayed feedback is not standard in online algorithm. So they require to develop a tailored algorithm for this one. To do this, they have a criterion called the regrade function. And the regrade function is actually the difference between the sum of utility functions and the policy chosen by the algorithm for all the jobs. This regrade functions could approach to zero when this term is increasing, or in other words, the number of jobs are increasing. So in other words, we can say that regrade function is proportional to the 1 over square root of the jobs available. So if the jobs are increased, or if this term is approaching to infinity, or maybe a very huge number, 1 over huge number is approaching to zero. So in evaluation, for sake of simplicity, they did not use the checkpoint overhead, and also they did not consider the delays that was encountered between switching from one Spot instance to the other Spot instance, or from Spot instance to the demand instance. They simulated two kind of data. One is the synthetic data, where they facilitate the debugging of the algorithm, and the other one is the real-time data, where they took the data from the EC2, which is the Amazon spot pricing history, and also they considered the map-reduced job traces. Here are the parameters which they considered. They considered 208 policies, and the job size was drawn almost at random. Similarly, depending upon the size of the job, the deadline were also chosen randomly. So they also designed the spot process throughout the experiment in random way. Here is the first simulation. They first choose the on-demand price to be equal to 0.25, and they set a lower price for the spot instances, which is 0.1 plus something times x, and x is a random Gaussian variable. So this is x is a random number, and for each instance, or for each spot instance, this random number is multiplied with 0.05, and it is this small number is then further added with 0.1, and something greater than 0.1 price is there available for any spot instances available. So when the distribution of jobs is less, for instance, they had 500 distribution. As I said, the number of policies were 208. For that much number of policies, this is the policy index. The probability of the policy to be chosen for accomplishing this task is not very specific. If you look, the policies are kind of seems random, like this policy, which seems at highest one, it is also not that huge probability. Like this policy had 0.016 probability to be taken for several jobs. So this is very less probability. And likewise, here a couple of jobs were serviced by these policies, and some of the jobs were serviced by these policies. But when the number of jobs were double, when they become 1000 instances, there you can see that the probability become better for certain policies. For example, this policy serviced more than 0.045 jobs. Some policies which also perform better, they had this probability to complete those jobs. And also there were the other policies which looks a bit random. Again, when they increase the jobs to 2500 jobs, you can see that it further improved. The probability of this policy has like almost 0.28, that it serviced almost this much of jobs. Almost 28% of this much jobs were done by this policy. The other policies, they didn't perform well. And when they have the exceptional large jobs, then you can see that above 70% or maybe 0.72 or something chose this policy to complete the task. So this was the most successful policy to accomplish the job. And what was the reason for choosing that policy? Because this policy had lower price and it was completing the job in time. Now, what they did again with the synthetic data, they kept the on-demand price again like this, 0.25, but they slightly increased, not slightly, they increased the spot pricing almost equal to this one. Not exactly equal to this one, but it is almost equal to this one. You can see that this is the spot pricing now. So how they did it? For the first 10% of jobs, they kept the price like this one, like 0.1 plus 0.05x. But for the 90%, for the remaining 90%, they increase the pricing, the spot instance pricing, like this much. If you carefully look at this one, this price is almost equal to the on-demand price. So on-demand price is fixed, it is costly, and it does not switch back and forth between the instances. Once it gets it has some reserve instances, it keep on that one, and it does not go back and forth. So it can guarantee to complete the job. But on the other hand, if we have this much of expensive instances in Spot, and then again we have to pay the price in terms of latencies of switching from one instance to the other instance, then this might not be able to complete our task. So their algorithm automatically only choose the on-demand instances, which is again by default 0.25, and they just discard the second one. So in this one, if you look, this whole scenario become kind of rate centric. They do not consider these spot instances anymore because they are more expensive, and they only focus on the on-demand instances. And if you look at here, their algorithm almost completed all the jobs, which is around 10,000 of jobs, and they have been completed. Some of them have been not completed, but they were very less. So compared to the non-completed, the completed tasks, which is the total payoff, they are quite huge. And then for the real data simulation, they consider the translate map reduce jobs in their model. And also the deadline was took as the job actual completion time from traces. They added the value, which is the job arrival, to the job deadline synthetically. So here is their evaluation. Here in this figure, when the prices were very fluctuating for the spot instances, they used variable bidding. But when the spot prices became stable, then they used fixed bidding for the rest of the interval. And from this result, they almost got 34 times best performance than the counterparts. So this is the related work. So you can go and take a look at these papers too, because these are all the related work. And to conclude this work, they use the online learning algorithm for choosing between the on-demand and spot instances, where they did not use the probabilistic assumptions, and they incorporated a variety of policies and also incorporated the deadlines. And they also can extend to many other resource allocation scenarios in cloud computing. And future directions, they could maybe include some more scenarios, and they could also including reserve instances. Reserve instances, I would just tell you a little bit about this one. When you have like a very long project, for example 1 or 2 years of project, and you want to buy reserve instances, then you have to pay for at least 1 or 2 years in advance. And then each time you are going to access the resources from the cloud, you will be getting special discount in reserving those kind of instances. For example, you are reserving any time in a day for 2 hours, rather than the on-demand prices like $100, you might be getting those instances with $30 or $40. You may have like 30 to 70% of discount and purchasing this one. So in future, they also intend to include the reserve instances, and then they compare the online algorithm between the reserve instances, online, and spot instances. Now, I would like also to answer the 3 questions. The first question is why this problem is important. This problem is important because in a given time frame where we have to complete a task with lower possible cost, we always are looking for a good solution. So the good solution could be anytime spot instance, or it could be on-demand instance. So the problem is important because they give a joint solution for complete the task with the lowest cost. The novelty is they devise a solution where they propose to choose between the best, which is on demand, and the stop instances with reduced prices given that to achieve their goal. And regarding my impression, I took a look at this work in Google Scholar, and I found that it has not been cited. And I believe that the main reason behind this is because they did not evaluate it thoroughly. They did not use enough scenarios. And the other one is they do not have more practical things. Like they mostly their evaluation are simulated tasks, like they are doing some simulation. So if they had some real-time test bed and they had evaluated, it could have been a very good work. They have like 91 citation, but in this given time frame, I would say that my impression is it's not that much big.